In Creo Parametric, you can create belts and pulleys in mechanism mode. I was looking at my engine assembly. I noticed that there are a couple of subassemblies with belts, and I decided to turn them into real actual moving mechanisms instead of static components. Let's take a look at how to do that. I'm going to jump over to another window that contains one of those subassemblies. If you take a look in the model tree, there are 4 different components, and the first one is a part for the auxiliary belt. I'm going to grab this and try to move it down to the bottom of the model tree out of the way, and there it is. Just don't want to be using it right now. Let's go to the first component here, the damper pulley. I'm going to edit definition and take a look at the constraints. I can see that there are 3 different constraints in the model. We have a coincident constraint for the axes, and then there is a distance constraint from a plane and a parallel constraint. This parallel constraint is preventing this component from rotating. I want to have a pin connection. So I can right click on the component and choose delete, and then uncheck the option to allow for assumptions. Now we are partially constrained. This button in the ribbon will convert the constraints to the corresponding connection. Here I have a pin connection that is good. Let's hit the check mark. That's good for the first component. Then let's go to the second component. Once again, I will edit definition and follow the same process. Let's go to the parallel constraint, right click and delete it, uncheck allow assumptions, convert to mechanism. We have the pin connection, and I can middle mouse click to complete that one and repeat that for the third component. Delete the parallel, uncheck allow assumptions, convert to mechanism, hit the check mark. So now I have 3 different pin connections here in the model. For now, let's say I want to suppress this particular component. I can right click on it and choose suppress. Here I get an issue. It says, hey, if I want to suppress this, I have to suppress some other stuff. Let's go to the options button, and then there are no local children. If I go to external children, well, it looks like it's got to suspend this feature, which looks like a data sharing feature. If I expand the model tree, we can see it right there. There's a curve inside of this part, and it's also got to suspend protrusion ID 185, which actually doesn't belong to this particular component. Let me cancel out of here and then cancel out of here and figure out where that protrusion is. I will right click on aux belt 1 and then go to information, reference viewer, and in the dialog box, let's make this a little bit wider. Okay, we've got curve ID 51 inside of aux drive 1 skeleton. I can also expand this. Okay, so it's also got a parent that uses this coordinate system. But over on the children, I see that damper pulley PRT. This is the one that has that protrusion, which has a reference to the auxiliary belt. Let's take a look at breaking that particular reference. Let's close out of here. Let me click on the part and then use open from the mini toolbar. There is a family table. I'm going to work on the generic. And here is protrusion ID 185. You'll notice that it's got the double box glyph next to it in the model tree. That indicates that this feature itself isn't fully constrained, probably because we have the mechanism connections. This one is kind of like not fully defined or not fully fixed. Let's edit definition of the protrusion, and I can see that it is a revolve. Let's go to the placement tab. It has an internal section. I will click on the edit button, and then let's take a look at the references, and we can see, okay, it's actually referencing 2 surfaces from the aux belt component. Well, let's break that reference. I'm just going to delete that reference, delete the second reference. Let's hit the solve button. It's fully placed. It's got some weak dimensions in here. I'll leave them there as weak for now. Normally I would change them, but for the sake of this demonstration, I will not. Let's hit the check mark. Now that double box went away in the model tree. Let's go back to the assembly window. Let's see if we can suppress this. I will click on the suppress icon. If I go to options, the only thing it's going to suspend is the data sharing feature in there. So let's click OK in there for now. Now we can create our actual belt feature by going into mechanism mode. I will go to applications and then mechanism, and in the ribbon I can locate the belts command. And so then for references, it wants me to pick some cylindrical surfaces. Now the problem that I have here for the actual surface where I'm going to put it, let's select, here we had it a second ago. Let's grab, say, this surface here, but I think the surface I got was actually too low. It's not where I want the belt to be. And again, the issue that I have over here is that with the cuts made in here to create the different grooves in the pulley, I don't have a surface where I want them to be. So I've got to do a little bit of extra work. Let's cancel out of the belts command. Let's get out of mechanism mode. I got to do a little bit of extra work. Let's go to the first component and open it up. Again, I will go to the generic, and for this belt, it's going to go around the bigger diameter, and I'm going to find a position in the model tree before these cuts. Let's go in here, and I will go to insert mode, insert here. I'm going to copy these surfaces so I can use them later on. Let's select one surface, hold down the control key, select the other surface, and then right click and copy. Then right click, and I can use the paste command. And then I will just hit the check mark to make a copy of those surfaces. Then I can right mouse click and exit out of insert mode. And those surfaces I copied are sort of covering up over the grooves, and I still want to see them, but I still want to be able to select the surfaces. So I'm going to do a little trick. Let's go to View Appearances. I'm going to find a transparent color in the model. Let me expand plastics, go to plastic clear. Here is a color that I can use. It is translucent clear, and I will select this copied surface, hold down the control key, select the other copied surface, and then hit the OK button or middle mouse button. And so now the part looks the same, but if I'm trying to pick a surface, let me go to the selection filter. I can grab a surface exactly where I want to use it in order to define the belt location. So again, just a little trick of creating a copied surface and then making it invisible. Let's get out of here. Let's go back to the assembly and do the same thing for the other two parts very quickly. All right, now I have some surfaces that I want to use. Let's go back into mechanism mode, applications mechanism, and then go back to the belts command. And really for the first belt, I'm going to pick over on this surface. Let's grab that one. And the second reference that I want it to have, let me choose, holding down the control key, this surface. So you can see the pulley that we're getting. And for the third one, let me hold down the control key and grab here. And Looks like I got it right the first time. Sometimes you might have to play around with reordering them or using the flip button if you get them twisted in the wrong way. So for example, if I hit the twist, hey, you can see the alternate ones that we get. In terms of the belt plane for the model, I don't have to fill that out, but if I wanted to specify the plane, I could figure out which one of these planes over here in order to create it. But it looks like it's creating it right in the middle of the surface where I want it to be. Here we have the EA value that helps us define the tension. And Young's modulus times area actually ends up in a unit of force because Young's modulus is in force per unit area. Multiply that by an area, you get a force. And I looked up a typical Young's modulus for a timing belt, and it came out to about 12,500 newtons per millimeter squared. I went into the other model and measured the cross-sectional area of the belt that they're using. That came out to 53.2 square millimeters. So for my EA value, this is going to be a value of 665,000 newtons. And everything else looks good. Let's hit the check mark in order to create the belt in the model. Now I can right-click on the belt and choose to make a part. And here we have the component creation dialog box. For this one, I am going to call this the aux drive 1 underscore belt, and then click the OK button. For the creation options, let me use the browse button, and I'm going to grab my Creo 7 metric start part. Let's actually grab, which one do I want? Let's use this one over here, and then click the open button, and then OK. And I've got the component placement dialog box. I can just locate it using the default constraint and then hit the check mark. Right now it's got the datums visible. Let me use my model tree in order to make them no longer visible. I have a part. I can create geometry in here. Let me go back out of mechanism mode for a moment. Let's select this belt part and open it up. And so beforehand, in order to see the geometry, I took a look at some of the different features in here. There is a protrusion, a sweep for the bottom, and then for the different grooves, there is another swept protrusion that is then patterned. And so I took a look at the different dimensions in there. Let's go about putting in our geometry for this belt. So let's select the belt part, the new one, and then open it up. And all I've got here in my model are a bunch of curves. Let's create a sweep. So I will click on the sweep command. The first thing I need to know is what trajectory do I want to use. And I can click on here with the left mouse button and then use the shift key in order to build up my main trajectory. And here we can see the direction that the feature is going to be created. I am fine with that. Let's click on the sketch button. And the sketch in this particular case, for the base of it, it's just going to be a rectangle. I will use the drop down and go to the center rectangle command and drag it out about yay big. Then for the dimensions based on the other part, this is going to be a value of 1.6. This is going to be a value of 1. And this width dimension, this is going to be a value of 14.68. Let's hit the check mark. And there we have the base of the belt shape created. Let's hit the check mark. And so that's good for the first shape. Then for the protrusion, let me jump back over to that other part for a moment. This was the original belt. If we go to the protrusion, we can edit definition. This protrusion was created in an old version of Creo Parametric, which is why we are getting the old model dialog box. So what I did, I went to the section and then hit the define button to get into sketch mode, and we can see what the shape looks like. And I could have just taken the dimensions and figured out how to recreate it, but instead I hit the save button when I was in sketch mode in order to save this sketch out to disk, and then I found it where it was on my computer. I renamed it and dropped it into my palette folder, so I should be able to access it from this button. Let's cancel out of here, and let's go back to the other window. And to create our second sweep, let's go to the sweep command, and I will once again pick the same references, holding down the shift key in order to build up the trajectory that I want to follow. And one more shift and grab this entity. All right, so there is my origin curve, just making sure that I have a single trajectory. Let's go into the sketch and look over here to where we are. Then let's go to the palette button. And if I go here, I have one called Belt Groove. Let me double click on it and just drop it into the screen. Looks like it is rotated. The first thing I'm going to do is change the scale to a value of 1. And then let's rotate it. I want this to lock in. Let's see, this should lock in probably right about down there. Let me grab this. Actually, I should be maybe this location here. Let's eyeball it. And so I will grab and drag and let it snap into that reference. Let's change the drag location to there. I think I want there to snap in over there. Yep, that looks good. Let's hit the check mark. And now that we have our sketch, I will hit the check mark again. So that creates our first groove in the model. I will hit the check mark again. And we need a pattern of these. By the way, I no longer need to see the belt curve. Let's right click on it and hide it. I will select the second sketch. And then I will use the pattern command, and instead of a dimension pattern, can't remember which dimension I want on there, let's use the option from the right mouse button to change this to a direction pattern. I'll grab this flat surface, and for the direction, let me grab this and drag it in the other direction. We actually want it to be a much smaller distance. Plug in the value. We want a total of 4 instances. Again, I just got these numbers by taking a look at how the protrusion and pattern were created in the part that already existed. So that looks good. We have our nice grooves in our belt created. Let's go back to the assembly window for the belt. And now we've got it in here. With the belt and the tension defined and everything in here, now we should be able to drag everything. So I'll click on the drag button. Let's click on this component. And if I drag, you can see how the damper pulley and the water pump pulley are rotating. We can't see the alternator pulley rotating, but that's just an optical effect. I'm going to grab this part. Let's open it up in its own separate window. And I'm going to create a cut on here just so that we can see the rotation. So let me create a sketch on this surface. Hit the sketch button, and let me grab references and snap into this surface. Let's just make a circle, and I'll just make a big circle. Let's change that value to 6. Hit the check mark, and I will do an extrude. Let's flip the direction, and then let's change this by right mouse button to remove material. Then I'm going to right click and then change the depth to through all. Just a nice big cut. Yeah, we wouldn't want this in real life. Let's also go to View Appearances, and I will grab a bright color. Here we go, this one will work, and color that surface a bright red color. Let me then turn off my datum display. Let's go back to the assembly window. And you can see where that cut is in that particular pulley. Now we can try dragging again. Click on the component. You can see that, yep, it is indeed rotating along with the other two components. It just doesn't have any natural geometry that allows us to distinguish that actual motion is going on in this case. So in that way, I have created an actual mechanism connection inside of my assembly. I no longer need this belt, so now we can actually delete it. And that's how you can use belts in a mechanism. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.